Let me read the question 15a now. Diagram 11 shows a line segment AC. Okay, it is given that point B divides the line segment AC in the ratio of m:n. As you can see in the diagram 11, you have the coordinate A, x1, y1, where in between you have the coordinate B, which is xy, and coordinate C is x2, y2 respectively, and it's divided in the ratio m:n respectively. That's what it means, guys. Okay, so the question asks to show that y is equals to ny1 plus with my2 divide with m plus with n. Okay, so in this case they ask us to express only in terms of the coordinate y, not the whole coordinate itself. Okay, so I hope I made myself clear in this question 15 part A. So continue to read for the question 15 part B. Okay, it is given that coordinate P x y moves such that its distance from coordinate R, which is 3/2 comma negative 1/2, is 2.5 times its distance from the y-axis. Find the equation of locus of P. Okay, so this is the question 15 part B. Okay, we have take a look at the question 15 part A and part B question. So let us take a look at the question 15 part C now. Let me read the question 15C now. Diagram 12 shows the points P, Q, R and S on a Cartesian plane. It is given that coordinate W, X, Y moves such that its distance from point P and point R is always equal. Okay, it means that the locus W is actually a perpendicular bisector. That's what it means. Okay, so let me continue to read the remaining question. If the area of the quadrilateral PQRS is 60 units square, find the y-intercept of the straight line PQ. So this is the question 15C. Okay, so take your time to solve the question 15 part A, part B and part C, and we will begin the discussion in the count of 5, 4, 3, 2, 1. Let us begin our discussion for the question 15 part A, where we need to show that y equals to ny1 plus with my2 divide with m plus with n. So if you take a look at this question 15 part A, it is actually showing a line segment concept, where in the diagram 11 the coordinate B is actually in between of straight line AC, which divided into a ratio of m:n. So usually what we will do, okay, in order to find the line segment coordinate, which is the in between coordinate, so we will straight away use the line segment formula. But in this case, what we need to do is we only need to show the one part of a coordinate, which in this case is the y part. Okay, so from here I'm going to show you some of the method that you can use in order to show that the y expression. Okay, so the first step what I will recommend to the student is you do the sketch. Okay, a simple sketch. So from here, okay, this is your coordinate A, which in this case is x1 comma y1. Okay, this is your coordinate B, okay, which in this case is xy. Okay, and this is your coordinate C, which in this case is x2 y2. Okay, so far so good. So from here we divided this two portion into the ratio of m:n respectively. Okay, so from here what I'm going to do is we're going to focus on the y coordinate only, guys, since in the question they only ask us to show that the expression in terms of y, okay, the line segment part. Okay, so from here, so since we are only need to show the y part, so what I'm going to do is I'm going to do the comparison of these two particular segment. Okay, since this portion m and portion n is actually two straight line with two different coordinate, so what we can actually do is we can do the comparison of the gradient of the line and we can do the comparison in terms of ratio. Okay, so sound confusing? Okay, don't worry. Okay, I'm going to show it to you now. So we're going to do the comparison of the two straight line, and we're going to compare it in terms of the ratio that provided by the question over here. Okay, so let me guide you one by one. So let us begin with the segment N first. Okay, so since we need to calculate the portion Y, okay, so from here to equate in terms of the ratio N, so what we do, Y2 you minus with Y, okay, and then we're going to divide with this portion M. Okay, in this case is Y minus with Y1. Okay, divide with Y minus with Y1, so we can equate it in terms of the ratio of the line segment. In this case is N divide with M. Okay, so from here Y2 minus Y, so we can equate it in terms of N, and Y minus Y1 we can equate it in terms of M. Okay, so from here we cross multiply these two, so from here you get M Y2 minus with My equals to N Y minus with N Y1. Okay, so for the next step, what you're going to do is we're going to group the Y coefficient in a side. Okay, so we're going to move this negative My into the right hand side, and this negative NY1 to the left hand side. So from here you get My2 plus with NY1 is equals to NY plus with My. Okay, so from here, so we shift the equation Ny plus with My equals to My2 plus with Ny1. Okay, actually this particular step you don't need to write in your exam. You can straight away omit this step and then go for the next one. I'm showing this for the learning purpose, guys. Okay, so from here you factor out the Y. So you factor out the Y, you get it here N plus with M equals to, okay, so from here still the same My2 plus with Ny1. Okay, so from here to get the Y coordinate, what you do, okay, so to get the Y coordinate, what you do, My2 plus with Ny1, so you divide with N plus with M. So from here you get your answer My2 plus with Ny1 divide with N plus with M. If you wish to write Ny1 first, also can, guys. Okay, it's the same by the way. Okay, so from here let me underline the solution. Let us proceed our discussion for the question 15 part B, where we need to find the equation of locus of P. Okay, so from here the first step what we need to do is we need to form the basic mathematical equation to find the equation of locus of P. So from here we know that P is actually the moving point from the fixed point R. So the moving point P from the distance point R is actually 2.5 times distance from the y-axis, guys. Okay, so from here since we are expressing in terms of y-axis, so the equation that we're going to form is PR equals to 2.5x. okay, so from here let us continue. So this PR we can able to form using the distance formula. Okay, so from here P is actually the moving point, so we're going to minus with the coordinate R. Okay, so we're going to minus x minus with the coordinate r, the x coordinate r, which in this case is positive 3 over 2. So why we write here x? So the x can be any point, guys, within the x coordinate, so that's why we write here x. So square plus with y minus with negative 1 over 2. So this is the y coordinate of r, close bracket, square. Okay, and then don't forget to square root since we are using the distance formula. Okay, and then make sure that it equals to 2.5x. okay, so for the next step, so I would recommend the student to change this 2.5 into the fraction, guys. So why is it so? To standardize everything. Okay, if you're dealing with all decimal, then it is better to leave it in this way, but since you are dealing in one side fraction, it is better to standardize this into a fraction as well. Okay, so from here, so for the next step, so what you're going to do is we're going to combine these two separate equation into one single fraction, guys. Okay, so from here, let us do it one by one. Okay, so from here you get 2x minus 3 divided with 2 square plus with 2y plus with 1 divided with 2 square. Okay, and then you equals to 5x over 2. Okay, so for the next step, what you're going to do is we're going to square the both side equation. Okay, square both side equation. So from here you will be having 2x minus 3 divided with 2 square plus with 2y plus 1 divided with 2 square equals to 5x over 2 square. Okay, so let us do the expansion one by one. So in this part you need to be careful, so don't make any silly mistakes. Okay, so let us do it one by one. Okay, begin with this numerator. So from here you get 4x square, so minus 12x plus with 9, and then you divide with 4 excuse me, guys. Okay, plus with 4y square plus with 4y plus with 1 divide with 4. Okay, and then equals to 25 x square over 4. Okay, so from here, as you can take note, both side equation we have the fraction over 4, guys. So what we can do is we can times the whole equation by 4. So times by 4. So why we times by 4 both side? So very simple for us to eliminate the fraction. Okay, so times 4. So from here you left with 4x square minus with 12x plus with 9 plus with 4y square plus with 4y plus with 1 equals to 25 x square. Okay, so we are very close to our final step. So this 25x square, from the right hand side you move it over to the left hand side. So do it one by one, solve the highest power first, start with the x variable. So 25x square, so you move here, you will become negative. So negative 25x square minus 4x square, you get is negative 21x square. Okay, and then minus 12x. Okay, and then followed by the y variable plus with 4y square. Okay, and then plus with 4y. Okay, and then you plus with the two numbers 9 plus 1. Okay, plus with 10 equals to 0. Okay, so this is your equation of locus of P, guys. Okay, so this is your answer for the question part B. Okay, so from here, hang on, we will begin our discussion for the question 15 part C now. Let us begin our discussion for the question 15C, where we need to find the y-intercept of the straight line PQ. Okay, so in this question, we need to use the concept of the area of the polygon concept, guys. Okay, where they already give in the question that the area of the quadrilateral PQRS is 60 units square. Okay, and then you might wonder what is the purpose of the moving locus point W. Okay, there is a reason. Okay, so the first step, what you need to know is you need to know what is the locus W is. Okay, so from here, the locus W moves such that the distance from point P and point R is the same. That means that this locus W is actually a perpendicular bisector. Okay, perpendicular bisector means that whatever distance or area, regardless of distance or area, it will be equal. It will be portioned equally. Okay, so from here, let me draw the area of the quadrilateral PQRS. Okay, just light sketch. Okay, so assuming that this W, okay, I mean not assuming that, okay, this is based on the sketch, guys. Okay, so this W is a perpendicular bisector, so from here we can conclude that the portion of the PQS and QRS, they are the same, and they already give us that area of the quadrilateral PQRS is 60 units square. So from here we can conclude that this first portion is actually 30 units square, and the second portion here is 30 units square. So why we need this information? Because the question only asks us to find the y-intercept of the straight line PQ. So from here, what we can do is we only use this one particular set of information to find the y-intercept. So in this case, this first portion is 30 units square, and the second one is 30 units square. So we use this first set of information to find our y-intercept. Okay, so this is the overall idea on how we're going to solve the question 15 part C. Okay, so I hope you guys are clear. So let me guide you one by one in order to solve this question. Okay, so from here I will guide you on the using of the area of polygon formula. So from here, 1/2. Okay, so to use the area of polygon formula, okay, you can use either clockwise or counterclockwise, so it is up to you. But if you start with a point, you must end with the same point. Okay, let's say in this case, for example, I start with point P and then followed by point Q and then point S. So I must end with the point P again. It is actually a closed loop. So that's how it will be easy for us to find the area. Okay, if you left out this one last point in your working, your answer will be inaccurate. Okay, so from here, let us begin. So by writing with the coordinate P. Okay, coordinate P, since it is a y-intercept, so our x coordinate will be 0. Okay, the y coordinate we don't know yet, so we just write here y. Okay, continue with the coordinate Q. So the x is 2, y is 12. Okay, coordinate S, 8, 9. Okay, and then you end with the coordinate P again, which in this case is 0 and y. Close modulus equals to 30 units square. Okay, so for the next step, what you're going to do is we're going to times by 2 in the both side of the equation, of course, to eliminate this fraction. Okay, so times 2. So from here you get 0y 2, 12, 8, 9, 0, y, okay, equals to 60 units square. Okay, so let me guide you one by one. So 0 times with 12 plus with 2 times with 9 plus with 8 times with y. Okay, so this pencil indicated direction, so you need to times them and plus them aside. Okay, and then this red symbol you need to minus them. Okay, y times with 2, 12 times with 8, and then 9 times with 0. Okay, so let me show you the working if you don't understand. Okay, so from here 0 times with 12 plus with 2 times with 9 plus with 8 times with y minus y times with 2, okay, plus with 12 times with 8 plus with 9 times with 0. Okay, close bracket, close modulus equals to 60 units square. Okay, we solve this part first. Okay, 0 times with 12 you get is 0, 9 times with 12 you get is 18, and then plus with 8y. Okay, so from here 18 plus with 8y minus with 2y plus with 96. Of course this one is 0 guys, 9 times with 0 is 0. So from here equals to 60 units square. So this negative you times in. So from here you get 18 plus with 8y minus 2y minus 96 modulus equals to 60 units square. Okay, so from here 8y minus 2y you get is 6y. Okay, 18 minus 96 you get is negative 78. Okay, and then make sure you put the modulus symbol equals to 60. Okay, so from here the modulus we're going to move it to the right hand side of the equation. So from here 6y minus 78 will be equals to plus minus 60. Okay, and from here we're going to have two possible answers, because anything modulus you have positive or negative input, it will result in a positive output. Okay, so from here 6y minus 78 equals to 60, positive part. So 6y minus 78 equals to negative 60. So this is the negative part. Okay, so from here 6y will be equals to 60 plus with 78. So from here you get is 138. Okay, so from here 6y equals to 138. So you solve this, you should get your y is equals to 23. Okay, now focus on the negative region. So from here 6y negative 78, so this negative you move it to the right hand side will become positive. So from here negative 60 plus with 78, so from here you get your 6y equals to 18. So from here 6y equals to 18, so from here y is equals to 18 divided by 6, so that's how you get your y equals to 3. Okay, so now you have two set of answers. So from here, which one you can use it as a y-intercept? Okay, take a look at the sketch again. So from here, you have your position P. So logically, you can't have your y equals to 23. So the appropriate and the most accurate answer is this, y equals to 3. So this is the only valid answer. your y cannot be equals to 23, so you can only have y equals to 3. So this is your answer. So this is your y-intercept, guys. So I hope you find this video useful. If you like this video, please make sure that you give a thumbs up. If you haven't subscribed to the channel, please subscribe to the channel and hit the bell icon for more upcoming Math tutorial videos in the future, and make sure that you share this video to your friends. Thank you everyone for your support, and I'll see you in the next video.